Hello everyone, my name is Shantanu Patil along with my team members Vivek, Rahangdale and Mohit Dabhekar are going to present you our internship presentation on IoT based home automation system. First, I will like to thank Emertxe Information Technology to provide us this opportunity to do the internship. Our project guide was Jay Lakshmi N. Daniel. So let's look at now. So first we will look at the contents of our PPT. Now first we will take a look at what is IoT, then what are embedded system, and after that C and C++ language that we use to program embedded systems. After that we will talk about the project we have made, and we will look at the project screenshot, and finally we will look at the conclusion. Now what is IoT? The Internet of Things or IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animal or people that are provided with unique identifications and the ability to transfer data over a network without requiring human to human or human to computer interaction. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transporter, an automobile that has built-in sensor to alert the driver when its pressure is low, or any other natural or man-made object that can be assigned an internet protocol address and is able to transfer data over a network. Now next is what are embedded systems. As the name suggests, embedded system means something that is attached to another thing. An embedded system can be thought of a computer hardware system having software embedded in it. Now you can see embedded system basic block diagram here. Here it is a sensor, analog to digital converter which can be used to convert analog data to digital data, and a memory to store the data, and after that a processor to process the digital data. After that it will convert it into the digital data to the analog converter, and finally the output is given to the actuator which finally perform the operation. Now next is embedded system. Here you can see the different devices that we have used in the different devices that can be used in embedded systems, like household appliances, electrical vehicles, implanted heart monitors, etc. Now what are microcontrollers? Microcontrollers are the devices which are used to perform a single task again and again. It consists of timers and counters, PWM, pin, processor, memory and input output ports, and all the required things that we need. Now we will talk about C++ language that is used in embedded system design. So some of the few basics that we have covered in C language are basic syntax and data types, operators and arrays. Operators means the operators that like plus, minus, multiplication, division, and arrays, functions and pointers, preprocessor, storage, classes, strings. And some basic of the few basic covered for C++ language are basic syntax and data types, classes and objects, construction and destructors. Now we will talk about the project. What is our project? Our project is home automation. The requirement of this project are IDE, Arduino UNO, simulation, Pixie app, controlling device using Blink app. The app is used to give give the output data functioning. So we will build the project successfully by writing multiple lines of code on Arduino using Pixie lab simulation that we have downloaded from the Emertxe website. In our IoT home automation system, we included controlling garden lights that function on LDR sensor, and the intensity of light depends upon amount of sunlight received. If there was no sunlight in the LEDs, would switch on, and if there was good amount of sunlight, the LEDs will go off. Next, we control temperature system including heater and cooler which would function sensing the temperature around. If temperature will rise above 35 degrees Celsius, the heater will turn off automatically and we will receive a notification on our Blink app that heater is turned off. Finally, we control the water tank system where we had to inlet and outlet fuel. If the water level of the tank goes below 2000 liters, we will receive notification on our Blink app that the water level is below 2000 liter and the inlet will automatically turned on. Finally, this is our simulation. So in our simulation here you can see all the components that we have used in it. Here it is a LCD 16 into 2 LCD display that is used to display the capacity of the water tank and their surrounding temperature. Here is the LDR and here is the garden lights, and this will control the intensity of the light. When the light goes off, this will turn on. When the sunlight goes down, this will turn off. Here is the Arduino UNO board that we have used, and here it is a tank, inlet valve, outlet valve, and this is the water you can see. So this is our project that we have built. So finally there is conclusion. Finally concluded, I would like to thank Emertxe for making this project successful. We were able to build IoT based home automation system and also control it using Blink app. Thank you.
So this is the Arduino IDE user interface where I have written the code for home automation project. We have created separate libraries as they are easy to maintain, and we will look at each of them one by one. First of all, this is the home automation main file. It consists of Blink authorization, device name and template ID, which we will get when we register the device on Blink app, Blink IoT Cloud app platform. These are some preprocessor directories which we need to include in order to use Blink as well as to use CLCD display. This is the function for the cooler pin which we display on the Blink IoT app in order to control the wheel. This is the code for the heater pin. Similarly, these are the code for the inlet and outlet where of the cereal tank. We also need to display the temperature on the Blink IoT app. Hence, this is the code for the same where we display the real-time temperature reading. We need to handle the that is when it is above the 35 degrees Celsius. We need to turn on the heater. We also print the notification on the Blink app. We also need to control the water volume above 2000 liters. Hence, create a function handle tank. It checks if the volume of the then it enables the tank. If the tank is full, then the inlet valve is turn off. Now this is the setup function which is called only one time. So we initialize the LDR that are guided lines. We also initialize the CLCD display, and we also print information. Then we call the temperature system, and we also initialize the cereal tank as a setup. Now next, this is the loop function. The loop function will run repeatedly. Next, move on to next file. It consists of a function initializing the garden lights, and it also consists of the function which controls the brightness. Then the brightness, there is a daylight, LEDs are turned off, and when their brightness is low, when there is evening and night time, brightness of the LEDs should be increasing. This is LDR header file where we define some macros for the LDR sensors as well as for the garden lights. This is the main header file where we define macros for on and off. We also define macros for the inlet outlet pins, cooler and heaters and pins, water volume gates, blink terminal pin and temperature gauge. Next, cereal tank file. Serial tank file will consist of a function initializing the serial tank. Then we define the volume function to get the real-time status of the volume of the tank. We define a function enable and disable inlet and outlet valve respectively. This is the serial tank header file. It consists of inlet and outlet valve macros, also macros and flow and height float volume enable and disable. This file is for the temperature system. We initialize the temperature system. It is the temperature using this function. This is the cooler control and heater control function respectively. At last, this is the temperature system of the header file, and it consists of the macros for the heater and cooler pins, where they are connected to the Arduino UNO board, and also for the temperature sensor and macro is defined. So this is the user interface. Here is a spare part window where we are arranged the CLCD display. As you can see, it is displaying the temperature as 27.34, which is the normal room temperature. To turn off the serial tank, which is currently 3000, that is the tank is full, inflow is off. This is the LDR system. These are the LEDs garden lights. This is the Ethernet used for internet connection of the Arduino board, and this is the temperature control system. This is LTM35 sensor. This is the cooler, and it has an heater. This is the Arduino UNO board through which 3 different spare parts are connected. This is the serial tank, which is connected currently to the serial port COM2. As you can see, it is currently full and the inflow is off. This is the outflow. Next, I will mirror my phone to the system, and we will control this different home components using the mobile phone and blink amp. So as you can see, now I have mirrored my phone. This is blink IoT app user interface. This is the cooler pin, interpin, real-time temperature reading. This is the notification terminal. There are two types, tap 1 and tap 2 respectively. Tap 1 is for the temperature system, tap 2 is for the inlet and outlet valve, that is for the serial water tank. Here the volume of the water, what is current volume is displayed. As you can see, it's currently 3000 liters. So first we will try to control the temperature system. We will turn on the heater and check if the temperature, that is 35 degrees Celsius, whether the heater is getting turned off automatically or not, or where it receiving the notification for the same for not. As you can see, the temperature is increasing. As soon as the temperature reaches the 35 degrees Celsius, we receive the notification that the temperature is above 35 degrees Celsius and turning off the heater. Now we will turn on the cooler. When we turn on the cooler, the temperature decreases and the fan starts rotating, and it rises to maintain the normal floor temperature. We will turn on the cooler now. Next, we will check the serial tank. So as you can see, the cereal tank currently it is full, and the inflow is off. We will try to turn on the outlet outflow and check if the level is less than the 2000, whether the outflow is getting out or off. As you can see, outflow is on now. Notification for the same is displayed on the CLCD, and the water level is also decreasing. When also is outer level is less than 2000, the inlet valve turned on automatically and is try to maintain the water level. Will turn on the outlet valve. Now the inlet valve will fill the tank, and when it reaches up to 3000 liter, it will turn off automatically. As you can see, the inlet valve is turned off automatically. We will check our notification. As you can see, the water level was 2000. Then we received notification turned on the inlet valve is full. We also need to the notification and turn off the inlet valve. Now the last system is data the garden light. This is the LDR system, and the light and the sunlight is when sunlight is maximum. When the sunlight is maximum, the garden lights are off. When the sun near it is nearly hitting at night, then the garden lights are brightest. That is the lighter turned on or off automatically. So this was the home automation project.